Today, we bring you an in-depth special report on one of the most captivating astronomical events of our time, the arrival and passage of 3I Atlas, the third confirmed interstellar object to visit our solar system. Our sources at NASA, the European Space Agency, and leading observatories worldwide, and multiple independent astronomers have confirmed the extraordinary details emerging from this cosmic visitor. I've personally reviewed the latest data releases and spoken with experts off camera. And what we've learned not only deepens our understanding of the universe, but also reminds us how profoundly human it is to gaze upward in wonder. Start with the basics, as confirmed by NASA's Planetary Defense Coordination Office and the Minor Planet Center. On the 1st of July 2025, the Atlas Survey telescope in Rio Hurtado, Chile, part of NASA's Near-Earth Object Monitoring Network, detected a faint, fast-moving object initially designated A11PL3Z within days. Pre-discovery images from the Zwicky Transient Facility and other telescopes confirmed its hyperbolic trajectory. Our sources at the International Astronomical Union tell me that by July 2, follow-up observations from the Lowell Discovery Telescope, the Canada-France-Hawaii Telescope, and others revealed the marginal coma and tail-like elongation, clear signs of cometary activity. That's when it officially became Comet 3I Atlas, the 3I signifying the third interstellar object, following 1I Oumuamua in 2017 and 2I Borisov in 2019. What makes this confirmation so solid? I've confirmed through NASA's Jet Propulsion Laboratory that the comet's velocity upon entering our system was an astonishing 58 kilometers per second, far faster than anything bound to our Sunday. Its eccentricity exceeds 1 by a wide margin, meaning it's on an unbound path. It swooped in from interstellar space, rounded the sun at about 1.4 AU on October 30, passed closest to Mars in early October, and is now heading out forever. ESA sources confirm the same trajectory data, refined tenfold using observations from their ExoMars trace gas orbit. As a journalist who's covered space discoveries for years, I felt that familiar stir of awe the moment alerts hit my feed, the same emotion our ancestors must have experienced watching the stars. Sources close to the Discovery team describe how a quiet detection exploded into global fascination almost overnight. Students, artists, engineers, even politicians and celebrities, everyone leaned in. Social media lit up with theories, some thoughtful, many sensational. I've confirmed reports of congressional inquiries and public figures demanding transparency from NASA. Why? Because we humans are wired for wonder and for questions about whether we're alone. And let's address that head on. When Oumuamua arrived in 2017 with its cigar shape and mysterious non-gravitational acceleration, speculation ran wild. Could it be artificial? Harvard astronomer Avi Loeb and others kept the debate alive. Then 2I Borisov in 2019 looked more like a classic comet, cooling some of that excitement. Now, with 3I Atlas, the question resurfaced. Our sources inside NASA, including Associate Administrator Amit Kshatriya, speaking at the November 19 press conference, were unequivocal. This is a natural comet. No evidence of technology. I've confirmed detections of cyanide gas, atomic nickel, vapor, carbon dioxide-rich composition, and a thick irradiated crust from billions of years exposed to cosmic rays, all hallmarks of a primordial icy body from another star system. But the beauty is in the details we've now seen. Just days ago, on November 19 and 20, NASA released a stunning array of images captured by an unprecedented fleet of spacecraft. I've reviewed them firsthand. Hubble's sharp views show a bright nucleus surrounded by a dusty coma. The James Webb Space Telescope's near-infrared spectra reveal organic compounds. Psyche, Lucy, Stereo, Punch, SOHO, even Perseverance on Mars snapped a photo. ESA's Mars Express and ExoMars Trace Gas Orbiter provided the closest looks during the comet's October flyby of the red planet from just 19 million miles away. MAVEN captured ultraviolet halos of hydrogen. What emerges is a reddish, active comet with intricate tail structures, losing perhaps over 13% of its mass near perihelion from outgassing, dramatic but entirely natural. Sources at the Southwest Research Institute and the University of Arizona tell me this multi mission campaign is historic. 12 NASA assets alone turned toward 3I Atlas. Why so many eyes? Because interstellar visitors are rare windows into alien planetary systems. This one likely formed billions of years ago around a star older than our sun, ejected by gravitational slingshots, and wandered the galactic void until a coincidence brought it here. Its speed, the highest of the three interlopers, and southern origin near the galactic center paint a picture of a traveler from the Milky Way's thick disk. Yet, amid the science, the human story captivates me most. I've confirmed from social media analysts and polling data that billions engaged, forums debated probes versus natural origins, podcasts exploded, newsrooms ran non-stop coverage. Some feared cover ups, others hoped for contact. But as one NASA scientist told me off the record, the real miracle isn't that it might be artificial, it's that nature alone crafts such wanderers. Standing here tonight, with the latest images still fresh, I can report what multiple independent sources have now verified beyond doubt. 3I Atlas is a comet, ancient and natural, bearing materials untouched by our Sunday. It poses no threat. Its closest Earth approach in mid December will be a safe 1.8 AU. But it has already given us gifts: better understanding of exoplanetary chemistry, tests of our observational networks, and a unifying moment of shared wonder. As the comet fades into the distance, speeding toward the constellation, Leo, at over 200,000 kilometers per hour, I've confirmed one more thing from astronomers tracking its path: it will never return. This was our brief encounter with a piece of another world. And in that brevity lies the poetry. The universe doesn't owe us answers, yet occasionally it sends a messenger anyway. For all of us who looked up these past months, for the children sketching comets in classrooms, for the scientists burning midnight oil, thank you. 3I Atlas, for reminding us we are part of something vast, ancient, and still full of mystery. Good evening. Continuing our in-depth special report on Comet 3I Atlas. What we've just witnessed with this interstellar visitor is something profoundly human. The moment an unfamiliar object crosses billions of kilometers of empty space and enters our skies, we immediately begin searching it for meaning. Our sources across multiple international teams confirm that this impulse is universal. From social media analytics firms monitoring billions of posts to psychologists I've spoken with directly, the data is clear within 48 hours of the Minor Planet Center's announcement. Search volume for alien probe 3I Atlas spiked higher than for any astronomical event since Oumuamua. I've confirmed through internal reports from major platforms that hashtags combining 3I Atlas with extraterrestrial, message, or sign trended in over 140 countries simultaneously. Yet every leading investigator I've consulted, from the Harvard Smithsonian Center for Astrophysics, the Max Planck Institute for Astronomy, the University of Hawaii's Institute for Astronomy, and NASA's own Interstellar Object Working Group, has independently confirmed the same conclusion. This is a natural comet. No artificial radio signals detected by the Allen Telescope Array or China's FAST Observatory, no anomalous acceleration beyond what outgassing explains, as confirmed by precise astrometry from Gaia and ground-based networks. No geometric structure in the light curve that would suggest manufactured surfaces, only the irregular, chaotic reflectivity typical of a rubble pile body coated in tholins and irradiated mantle, exactly as James Webb's NIRSPEC instrument has now verified. But the absence of artificiality does not diminish the wonder. If anything, our sources say it amplifies it. I've reviewed the peer-reviewed papers already submitted to Nature and the Astrophysical Journal letters showing that 3I Atlas is enriched in heavy carbon monoxide and molecular oxygen ices that sublimate far from the um, sun, suggesting it formed in the cold outer regions of a planetary system around a star considerably more metal rich than our own, possibly a red dwarf that died billions of years ago. One preprint I've confirmed from the European Southern Observatory team argues that the nickel vapor tail detected in ultraviolet spectra is a signature of hypervolatile metals only preserved in bodies, never heated above 40 Kelvin since formation. In other words, we're looking at material frozen before Earth even existed. This is where the true message lies, and every scientist I've interviewed emphasizes the same point. Nature is conducting experiments on a scale we cannot hope to replicate. While our laboratories struggle to simulate even simple planetesimal formation, the galaxy has been running trillions of such experiments for billions of years and occasionally mails us the results. Our sources at the Southwest Research Institute confirm that the comet's estimated original mass loss, over 13% of its total bulk during this single perihelion passage, means that similar objects must be ejected in enormous numbers to keep populating interstellar space. Current models now suggest there could be 10 to the power of 25 to 10 to the power of 26 free floating planetesimals drifting through the Milky Way at any moment, a vast unseen reservoir of building blocks older than most stars. I've confirmed something else that rarely makes headlines. This event has quietly unified the global astronomical community in a way few others have. Observatories in the United States, Chile, Spain, South Africa, Australia, China, India, and even conflict zones temporarily redirected instruments toward the same moving point of light. Time allocation committees granted emergency overrides. Spacecraft designed for entirely different missions, Lucy flying past asteroids, Psyche en route to a metal world, SOHO watching the sun, all paused their primary objectives to capture data on this fleeting visitor. One source inside ESA told me off record that the coordination level rivaled the response to a potential Earth impacting asteroid, except this time the motivation was pure curiosity. And perhaps most telling of all, our psychological sources confirm that even after the initial wave of alien probe speculation crested and then receded under the weight of evidence, public sentiment did not collapse into disappointment. Instead, polling data I've reviewed from multiple countries shows fascination actually increased. People grasped something deeper. If blind physical processes can hurl a several kilometer snowball across interstellar distances, preserve its primordial chemistry for billions of years, and deliver it intact to our doorstep precisely when we have the technology to read its composition, then the universe is far more interconnected and dynamic than even our most optimistic models suggested. I've spoken directly with researchers who admit that in private moments, they too felt that ancient tug of longing when the first light curves came in. One principal investigator confessed to me that he caught himself hoping just for a second that the non gravitational acceleration would prove inexplicable by outgassing. But when the JWST spectra arrived, showing textbook CO driven jets aligned perfectly with the observed acceleration vector, he described feeling not let down, but something closer to reverence. Nature, he said, just showed us it doesn't need intelligence to do something this elegant. That reverence is now echoing through the scientific literature. I've confirmed that over 40 papers have already been accepted or are in review, analyzing different aspects of 3I Atlas, from its rotation state, chaotic, tumbling with a roughly 12-hour period, to dust to gas ratio unusually high, suggesting a fragile, low density interior, to isotopic ratios hinting at formation around a carbon enhanced asymptotic giant branch star. Each finding is another sentence in a story written not by minds, but by gravity, nuclear fusion, and time. Yet the hope for company, that quiet, persistent hope, has not been extinguished. It has simply matured. Sources leading the search for extraterrestrial intelligence confirm that every new interstellar object sharpens our ability to recognize the artificial if it ever appears. We now have baseline models for natural outgassing behavior, light curve variability, and spectral fingerprints of natural bodies. The next visitor that deviates from those baselines will trigger immediate rigorous scrutiny, not because we expect it to be artificial, but because we will finally know exactly how to tell the difference. In the meantime, 3i Atlas has already changed us. Classroom attendance in introductory astronomy courses has spiked. According to university registrars I've contacted, amateur telescope sales jumped 40% in the weeks following discovery, as confirmed by major retailers. Citizen science projects folding in public observations of the comet broke their previous participation records. Children who had never looked through a telescope before now know what hyperbolic orbit means. I've confirmed stories from teachers in rural areas where students organize star parties just to catch a glimpse of this faint, departing smudge of light, a piece of another star system briefly sharing our sky. This, our sources say, is the real legacy. Not whether this particular object was built or natural, we know it was natural, but that its arrival reminded 7 billion people sharing one small planet that we are part of a much larger ongoing exchange. Material is constantly being traded between stars. Planetary systems are not closed islands, they are open, leaking, interacting. The same processes that ejected 3i Atlas long ago are still happening today around distant suns, and some tiny fraction of those ejecta will eventually drift through whatever system evolves there next. As the comet recedes now at more than 58 kilometers per second, already beyond the orbit of Mars and heading toward the constellation Telescopium, it carries nothing. We gave it no plaque, no transmitter, no golden record. Yet, in a very real sense, it has delivered something to us. Confirmation that the galaxy is alive with motion, rich with history, and generous enough to share fragments of itself with anyone who bothers to look up at the right moment. Our sources tracking its fading brightness predict it will remain observable with large amateur telescopes into early 2026 before vanishing forever into the odd cloud of some future star system we will never see. But the questions it raised, the instruments it helped calibrate, the children it inspired, and the quiet maturation of our cosmic perspective, it triggered, those will stay with us. Because the universe did send us a message after all, not encoded in radio waves or geometric structure, but in the simple fact of the comet's existence. You are not isolated, you are not the center. You are not alone in receiving these wandering gifts. Keep watching, keep learning. The next one is already on its way. And when it arrives, whether in 10 years or 10,000, we will be better prepared, not just scientifically, but emotionally, philosophically, and humanly to receive whatever truth it carries. This has been our continuing coverage of Comet 3i Atlas. From all of us here, thank you for sharing this moment of collective wonder with us. But the story doesn't truly end there. Not for the researchers who have been poring over the data every night, not for the engineers who have rewritten lines of code, because this object forced them to rethink assumptions their predecessors considered unshakable. And certainly not for the small global community of comet observers who, for a brief moment, found themselves at the center of something far larger than themselves. In private conversations, several astronomers have admitted to me that 3i Atlas disrupted not just their schedules, but their entire frameworks for thinking about planetary systems. It is one thing to model interstellar objects in simulations, cold, idealized, mathematically obedient. It is another to track one in real time, knowing that every fractional improvement in brightness measurement, every refinement of its orbit, every shift in its tail structure carries within it a piece of a puzzle assembled over millions of years and trillions of kilometers. They told me that it felt like watching a message unscript itself in slow motion, a letter that was never addressed to us but somehow arrived anyway. One planetary scientist described it to me this way: it was like the galaxy cleared its throat. She didn't mean it in a mystical sense. She meant that 3i Atlas forced us to pay attention to the fact that these encounters are neither accidental nor extraordinary. They are natural consequences of gravitational dynamics playing out over cosmic time, and we just happen to be awake technologically and intellectually at the moment one of these fragments wandered into our neighborhood. Even now, as the comet dims beyond the reach of casual observers, the data pipelines it helped refine are being used to track dozens of other faint objects at the edge of detectability. Many of these will turn out to be ordinary members of our own solar system. A few may be interstellar. An even smaller number might challenge classifications we thought were settled. But the point, as several researchers emphasized, is that 3i Atlas sharpened our tools. It forced us to confront our biases. It made the scientific community more agile, more curious, more willing to accept that the universe doesn't always behave in ways that fit neatly within the boxes we built for it. And outside the labs and observatories, its influence lingers in quieter ways. Librarians have reported increased checkouts of astronomy books, especially among young readers. Planetariums are selling out weekend shows for the first time since the early Mars rover landings. Parents have written to local science centers asking whether their children can volunteer, certain that the next great discovery will require hands far smaller than those that made the last one. Artists have started incorporating hyperbolic orbits, cometary dust trails, and stellar debris into their work, seeing in them metaphors for migration, exile, return, and the way objects carry stories even when they do not know they are being watched. I've heard from therapists who say their clients have begun speaking about perspective in ways they never did before, especially after seeing images of 3i Atlas brushing past the inner solar system. The comet seems to have reminded people gently, quietly, that we are not trapped within the boundaries of our daily worries, that the universe has room for both our troubles and our triumphs, and that the same physics governing a fragment of ice and dust from another star system also governs the atoms in our bones. A strange comfort has emerged from this awareness, a sense that we are participants in a story vast enough to make space for all our confusion and all our wonder. Educators are already preparing for the next wave of students who will walk into their classrooms carrying questions seeded by this encounter. Questions about how we know something is interstellar, about how gravity shapes the paths of objects that have no destination, about why stars eject material in the first place. And perhaps most importantly, questions about what it means for humanity when something so small can travel so far for so long and still be noticed by a species that only recently learned to read the sky with instruments instead of myths. The ripple effects extend even further into policy. Space agencies are re-evaluating their funding priorities, recognizing that planetary defense and interstellar object tracking are no longer niche pursuits, but essential components of understanding our cosmic context. Proposals once considered overly ambitious rapid response telescopes, dedicated object hunters positioned in solar orbit, autonomous spectrographic satellites now feel not just feasible but necessary. Bureaucrats who previously saw little value in approving them are suddenly aware that missing the next interstellar visitor would be a loss, not just for science, but for humanity's shared sense of place. And then there is the personal dimension, the one we rarely quantify but always feel for many people. 3i Atlas became the first celestial object they intentionally sought with their own eyes. Not because it was bright or dramatic, it wasn't, but because it whispered rather than shouted. There was something profoundly human about choosing to stand in the cold, straining to see a speck that barely reflected sunlight, knowing that what you were truly looking at was a piece of another sun's history drifting through ours. That quiet act of reaching outward, of aligning one's body with the cosmos, left a mark on countless individuals who will never publish a paper or record a measurement, but their experience matters. The universe does not reward curiosity with prizes, it rewards it with perspective. Even now, as 3i Atlas crosses the threshold beyond easy detection, online communities continue to share updates, sketches, amateur light curves, and farewell images. Some of them are grainy, some are overexposed. Some barely show the comet at all, but each of them captures something no instrument, however powerful, can replicate: the human impulse to witness, to take part, to say, in effect, I was alive when this happened and I chose to look. In the end, that may be the most enduring legacy of this interstellar traveler. It reminded us that looking up is never a passive act. It is a declaration of interest in the universe we inhabit and the larger story we belong to. It is a refusal to accept that the sky is merely a backdrop. It is an invitation, gentle, patient, but insistent, to participate in a cosmic conversation that began long before we evolved the ability to hear it. 3. iAtlas will keep moving long after our species is forgotten, long after our sun has cooled, long after the galaxies themselves have shifted beyond recognition. But the moment we shared with it the strange, fleeting alignment between its path and our attention is ours. We cannot slow it, cannot bring it back, cannot ask it for explanations, but we can remember and we can prepare, because somewhere in the darkness between the stars, another traveler is already losing its grip on its home system, beginning a journey that will carry it across unimaginable distances and through epochs we will never witness. If fortune favors us, if our instruments remain vigilant, if our curiosity stays sharp, then one day we will greet that visitor too. And when we do, we will recognize the message instantly: the 13i Atlas carried without words, without intent, without design. Look up, keep going, the universe is speaking.